Hey class, welcome. This is James Graves and we're going to get into another module here. This one's going to be a doozy. This is IPv4 subnetting and borrowing bits. This topic can be a pain in the butt for a lot of people. It's not tough. I promise you it's not. We're going to go through it. We're going to cover it a couple different ways, and once you see it and it clicks, it clicks. I promise you, you're going to be good to go after that. The other thing, make sure as we're moving through this that you already have a sound foundation in understanding your classes, understanding your default masks. You definitely have to understand data conversion. So we're going from decimal to binary and such. You got to understand that. And outside of that, though, I think we're going to be good to go. Let's go ahead and jump into it and see what we get. So I'm going to start first by looking at, well, if I can get to it, let's get this guy out the way. Here we go. Slide this up, and let's begin by setting an address up here. We're going to start with a class C. We're going to take this class C and we're going to chop this guy up into some smaller networks. What do you say? 207.12.120.0. Alright, that's going to be our network that we're working with. Let's get a mask. We got to understand our default mask at this point, which will be 255, 255, 255, and a 0. Couple things you should know when you see this right off the bat from our previous nuggets here, or maybe just prior experience. First off, we're talking this is a /24. Okay, that means that we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Those zeros look pretty bad, but we know what we're talking about there, right? The first 24 bits of this mask are enabled. That's what we're talking about. Remember, these guys have to build from left to right. We cannot enable any more bits to make adjustments to our network until we have enabled a bit before it. Okay, they have to go in order. Sorry, that's kind of bugging me. I just want to fix that. What else do we know? Well, we understand if we're dealing with a class 20/24, class C, 207.1.2.120.0 is our net ID. We understand 207.12.120.255 is our broadcast. Remember this mask value right here. These octets right here directly correlate with the octets above it. Understanding that an IP address can have any value from 0 through 255 or 256 potential addresses, and we subtract the mask value for that octet, we understand we have locked this guy to one address. Same here, we've locked him to one address. One address. This one, 256 minus 0. He's not locked at all. There's 256 potential numbers that could happen here in this octet, this fourth octet. Therefore, our first available is 0 and our last available is 255. 0 through 255 gives us our 256 addresses that we're talking about there. Now 207.12.120.1 all the way through 207.12.120.254, we understand that this is our usable range. This is what we can assign to devices inside our network. Alright? So what happens if we take a /24, and we're not going to go this way with it. but we will borrow bits this way. We will turn around and grab something like this next bit and enable that guy. What happens when we do something like that? Our /24, well, remember our values for our octets there, for our bit values here. A /25 means that our mask value is now 128. This bit has a value of 128. And what did we do to our networks? We enabled the first 25 bits now. If we do the same math that we've done over here, we're going to say 256 is what the potential is up here, minus our mask value for this octet. Now for this network 207.12.120.0, now we can only have 128 potential addresses in there. Okay? What does that mean? Well, we're going to go 207.12.120.0. We're going to go 207.12.120.127 as our broadcast 0 through 127. That is 128 addresses. Okay? This is a net ID. That's our network identifier. This is a broadcast. Now we have a different range. 12.120.1 through 207.12.120.126. This now is our range that we have available. What in the world just happened? Well, as we borrow bits, we understand a /24 and how many hosts that gave us. We can move this way and borrow bits, and as this mask value increases, okay, 255, 0 went up to 255, 128. As this value increases, the number of networks that we're creating increases, okay? But the host available in those networks decrease. So again, think of this guy as a sliding scale. So here's what's happening. As this mask value moves this way, as we borrow bits to our right, our networks, the number of networks actually goes up. We took one network, 207.12.120.0, and now we've divided that in half. Instead of going from .0 to .255, now we have two networks, a .0 to 127, and now also a .128 to 255. Now they're smaller. The networks are smaller. Our host, the amount of hosts we can squeeze in them went down, but we have created more networks. Now that might be very helpful in the case of, let's say that we have a tell you what, let's say I have in my home here, it's a two-floor house, a two-floor home. Let's say I want to make one network for upstairs, one network for downstairs, completely separate networks. Now why would I do that? Maybe I'm bored one weekend, I have no idea. But if I chose to do that and I did a /25, I could have a network of 126 hosts upstairs, or 128 total addresses, and 128 total addresses, or 126 hosts, usable hosts downstairs. Now when I say addresses and usable host, remember, these are part of the addresses for that network, but they get removed when we start talking about usable hosts. We cannot use a net ID, we cannot use a broadcast, so a usable range is what we're talking about. And that looks horrible, but you know what I'm getting at. A usable range, okay? Let's look at one more example. We're going to chop it one more time. We're going to go /26. Now remember, 8, 16, 24, 25, 26. We have borrowed these 2 bits. Our mask value becomes what? Well, we have to add these guys up here. And when we do such, this bit and this bit, we turn this one on, we turn this one on, the remaining bits are all off. Right now we're dealing with the last octet. Add these guys together, 128 plus 64, our new mask value now becomes, see if I can make this work, 192. That kind of works. Alright. Networks now. How large are our networks? Well, let's do it the decimal way, let's do it the binary way. I think the binary way is really quick, but decimal way so we understand what's happening here. This guy started with the potential of 256 addresses. Let's subtract the mask value for that octet. We're going to get to 64. We have networks that are 64 in size, or you can look down here and say, what's the last bit that we enabled? 64 was. That will also tell you the additive. Let me show you what I mean by an additive. 207, 12, 120.0. Use your additive of 64 because that's where our next network starts. 207, 12, 120, 64. That is our next network. Let's do it again. 207.12.120.128. 64 plus 64 gives us 128. So all we're doing is we're adding by 64 each time, and we are getting to our next network. 207, 12, 120, 192. Another additive of 64. Now we have our 4 networks. This is going to max us out because from 192, our 64 addresses from that point forward gets us to 255, which is the last possible value we would be able to have in that octet. We're in the last octet, that means we're maxed out. We're done, okay? If this is one network, that's our broadcast, that's our net ID, and our usable is anything that's a .193 through .254, or 62 different usable hosts. 64 in size of network. We lose this one, we lose this one. We can have 62 hosts in these networks. That same thing happens here. That additive is a really helpful piece because you might get something that says, what is the broadcast address of the third network? Well, do your additives. 0, 64, 128 first network, second network. We're at our third network. Go ahead and put your fourth network up there because you need the address right before this, right before 192, to get your broadcast of the network right before it. Okay, another analogy to use, we're going to increase this guy one more time so we can make sure we got this concept sealed. Another analogy to use, we have a whole pizza. Okay, now I like to eat, I love pizza, but here's the deal. One pizza is way too much for me. One network might be way too much for the amount of hosts that we're putting together. So we might need to take that network and chop it up, or take this pizza and chop it up. When we enable this bit, we double the networks. Instead of 1, we double that, and now we have 2. Okay? This side, 207.12.120.0. This side, 207.12.120.128. Okay? Enable this next bit right here. We double our networks. Instead of 2 networks, we now have 4 networks. So we're going from dot 0 to 63, dot 64 to 127, dot 128 to 191, dot 192 to 255. We have 4 networks we have created. They're smaller in size, less hosts. Every time we borrow this way, networks increase, but our hosts decrease. Okay? Let's look at one more example. We're going to take that bit and we're going to borrow the third. 1, 2, 3. Remaining bits are off. So what did we figure out by doing that? Well, 1, 2, 3, add those up. 128 plus 64 is going to take you to 192, plus 32 more is going to take you to 224. Our mask value becomes 2, 2, 4, or in shorthand, /27. 24 bits up to this point, 25, 26, 27. 27 bits after we borrow that. What happens up here? Well, what's the last bit we enabled? 32, right? So our networks are going to start every 32. That is our additive. In other words, we're going to have a network of 207.12. Let's put a 120.0, okay? With a mask value of 255.255.255.224. This is our first network. This is our mask value. What is our broadcast? 207.12.120.31. 0 to 31 is 32. Okay. What's our second network? Well, we said our additives are 32. 207.12.120.32. Mask value of 255, 255, 255, 224, or /27, because you might see that either way. You got to be prepared for that. And what is our broadcast? 207.12.120.63. That is our second network. Third network that we could create out of this arrangement is 207.12.120.64. Mask value remains the same. What is our broadcast? 207.12.120.95. Alright, so we're going 0 to 32 to 64 to 96, 207.12.120.96. This network is a /27. You should know what that means. 207.12.120.127. We have 1, 2, 3, 4 networks, and you can see we can keep going up here. Okay, just to not to bore you too much, basically what we would do is duplicate this until we reach the end of what we started with, which was 0 through 255. 255 would be our end. Our last network here would be a 207.12.120.224 all the way up to 207.12.120.255, and that is the end of the range that we had available to us. We had one network that had 256 potential addresses in it. We've chopped it up into now 8 networks that have 32 addresses contained within each one. And that's what we're doing when we're borrowing bits. Bits move to the right as we borrow, and as we borrow to the right, networks increase, hosts decrease. Here's another quick way that you can do that math if you wanted to. Some people prefer this way. How many bits did we borrow? 1, 2, 3, 2 to the n, or in this case, 2 to the third. Okay, 2 times 2 is 4, times 2 is 8. How many networks did we just create? The potential of 8 networks. We can go this way with it too and verify with our host. If we were to do this, how many? 1, 2, 3, 4, 5. Same equation, 2n, but now we'll go 2 to the 5th. This is counting the zeros, the hosts. 2 to the 5th gets us 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. How many hosts? Addresses do we have? Not usable. How many host addresses do we have? 32. 8 networks of 32 hosts. Okay? That will help you out tremendously when we get into very large networks. What else did we do with our pizza down here? Okay? When we borrowed the first bit, we went in half. We borrowed the second bit, we chopped it in half again and got to 4. Now we borrowed this bit. How many networks did we make? Well, if we got to chop both of those in half, we made 8 networks. 1, 2, 3, 4, 5, 6, 7, 8. And we kind of see the ranges here and how they all work, okay? If you get asked what's the usable range inside that network, well, it's everything in between. For this first one, it's .1 through .30. That's usable, okay? 0 through 31 is the entire range. 1 through 30 is your usable range. Let's get a little trickier, a little harder. Let's jump into a Class B. Took a moment here to bring up a Class B based address that we have here, alright? We have, it's not the start of a network this time. Last time I gave you the start of a network. This time I'm giving you an address. So we have a network portion and a host portion. We're going to break down networks, find out where he's located at inside that network. We're also going to do one more thing. I'm going to give you a number of subnets, and I want us to determine where this guy, how we divide this guy up to get to those number of subnets. So we're going to go that route first, go from there. So looking at this right off the bat, we understand that if we take this first bit, I'll change colors, let's make this red. If we borrow this first bit right here, we understand that this mask value becomes 128.0. Pay attention to where I'm writing this at. When we did a Class C, we started off with 255, 255, 255, 0. So we had a /24. This time we're starting with a /16. So we're borrowing in this octet. This third octet is the one of relevance right now. What does that do? Well, all it means is that we're dealing with more hosts to begin with. We're dealing with less networks that are possible, but we're dealing with more hosts. Okay, let's just see how it breaks it down for us. Starting off, we would see 181.32.0.0. That would be the lowest possible value that we could have here for this network. Okay, looking at this, we're also saying that this octet right here, a third octet, which had a potential of 256 values in it, now has a mask value of 128, which means 128 is the additive that we're working with here. We've enabled that. That 128 just happens to be the mask value as well as our additive value for our networks. 181.32.127.255 ends up being the last possible address of our first network. Okay? That throws some people off initially, but here's what you're doing. As we are building these networks, we're going, let's just assume the 181.32 is always going to be present in the first part of the address. This is how these guys build. When this last octet reaches a value of 255, The very next host becomes 1.0, then 1.1, 1.2. This process keeps repeating again. You end up with 1.255. After you reach that, you start with 2.0. So this last octet rolls first. Reaches the end, this guy increases by 1. He rolls again, this guy increases by 1 more. Alright, all the way up until you get to 127.255. How can you figure out how many hosts are in there? Well, 0 to 127 is 128 times 256 potential values of the last octet still. This guy is still a 0, which means 256 minus 0. This octet has a potential of 256 different values. When you multiply those out, you're going to get to 32,768. That's how many unique addresses exist in here. Now we have a usable range, right? We take the 2 away, we can have 32,766 unique devices inside this network. Alright? And that's after borrowing 1 bit. Our second network is 181.32.0. This guy's going to end at 255.255. Again, assume these 2 octets. Remember, those don't change. In this network, they will not change. So 181.32, 128.0 as your second network. Okay? And then 181.32, 255, that's your broadcast of that network. Okay. Your range is everything in between. So it's 128.1 all the way down through 255.254. That is your range inside this network. Alright, now let's get a little tricky here. Let's say I come to you and I say, hey man, I need to make this into 760 subnets, subnetworks. That, looking at this on the surface, you might be thinking, wow, okay, how in the world do I take this guy and carve him up so much? Well, look, if we enable this bit, we know we now have created 2 subnetworks, right? This was one original network. We go to a /17 and we have made 2 subnetworks. Well, 2, what happens if we enable the next bit? We've made 4. We've made 8. We made 16. We made 32. We made 64. We made 128. We made 256. Enable the next bit, we made 512, 1024. Where does 760 fit? Well, it's kind of in the middle of those 2, right? But here's the deal. Let's say I owed you $760. Would you want me to come forth and say, hey man, I can give you $512 and that's all I got, sorry? Or would you want me to come forth and say, hey, tell you what, I'll give you 1,024 because I'm sure there's some interest on top of that. You always go with the larger number, okay? If we go to this guy right here, we will make 1,024 subnets, okay? How many hosts will be inside those? You'll go this way to get that. How many subnets? You go this way to get that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 to the 10th power should get us to 1024. We borrow 10 bits. We'll see if we're right. We take 2. We're going to go to the 10th power. We borrow 10 bits. We have 1024 subnets that we can establish out of our initial Class B network here. Alright, let's go one other way with it. How many hosts do we have? 1, 2, 3, 4, 5, 6. 2 to the 6th. So these are networks of 64 in size. What's the last bit we enabled? Well, if you, I don't want to confuse you here. Let's get this guy over here so we can look at this. There's our divider. So we got the first bit is enabled, correct? And we enabled the second bit, 64. Okay? Networks are 64 in size. There's 1,024 of them. What is our mask value? Okay? This guy's maxed out, this octet. So he becomes, scratch that out, he becomes 255 here. Scratch that out, 128 plus 64 is 192. So now, what are we looking at from a bit standpoint? Well, 8, 16, 24, 25, 26. This has now become a /26. We borrowed 10 bits from a /16. We borrowed the 10. We're now at a /26. If that happened to be the case, and I said, here's the deal. I got to find this guy, this host, inside of these networks. How would we go about doing that? Well, let's write down what we know. As of right now, we understand. Let's get to our very first network. That's our first network. What is our mask value? We understand it's a /26, or in other words, a 255, 255, 255, 192. Where is our next network going to begin? Well, what octet are we referencing? Here's our flexibility right here. Here's how they're going to build. 181, 32, 0, 64. That's our second network. 181, 32, 0, 128 to 192. Now watch this. This guy's going to rotate back to 0. He's going to move to 1. 181.32.1.0 is another network. 181.32.1.64 is another network. Okay? What we're doing is we're saying whatever this guy's set at, he's going to stay, he's going to stay, he's going to stay, and he is going to roam from 0 through 63 or 64 through 127, so on and so on and so on. Okay? This continues on. We have to get to 64. 181.32. Knowing this guy will increase by 1, 64 is a valid beginning there. 31. We can have that network. We can have that network. Where is this host? He is going to be right in the middle here. This happens to be the network he exists on. 181.32.64.0 is his network address. He is host 31 on that network address. This stuff on the bottom, host, that's default. It's not valid now. Now this is network, and portions of this is network as well. This is net and host, depending on where your value is. If this guy happened to be, instead of a 31, he happened to be 128, this value is 128, that would be the start of a network. That would be a net ID at this point, because of how many bits that we've borrowed. We went this way. Our networks have increased. Our hosts have decreased. Okay? Let's look at a class A, and I'm going to pull out a little cheat sheet to help us on this one. All right. Now this thing is a monster to get on the screen, but this is a very helpful tool, and it's something that you can actually draw and write inside your book. At the end of this, for a couple seconds, I'll put up a class A, a B, and a C bit borrowing sheet, and then if you want to pause the video and write them down so you can get some assistance from it, feel free. These things are awesome to have. So we're looking at a network right now. It's a class A. It's 23.0.0.0. I'm going to give you the network address. And let's say I said, I tell you what, man, I need 7,824 subnetworks out of our initial one. We're starting with one network, 23.0.0.0. 24.0.0.0 is a completely different network. 22.0.0.0 is a completely different network. So we have one network here of 23.0.0.0. What is our mask value for that? 255.0.0.0. Here's what we end up doing. If we borrow this first bit, what happens? Well, we're starting with 16.77 million addresses. If we borrow this first bit and it becomes 255.128, we have created two subnets. Those subnets have 8,388,608 possible hosts inside each one. That's by borrowing the first bit. If we borrow the first two bits, and that's what that octet looked like, what would we know? Networks would have additives of 64. That's the last bit enabled. This guy right here equals 192, so that would be the actual decimal format here, 192.0.0. We would have created 4 subnets. Is that true? Well, 23.0, 23.64, remember, additives of 64, 23.128, and 23.192. That would have been our 4 networks of 4,194,304 host addresses. Now usable, subtract 2, and you get your usable. Hopefully you can see how handy this guy is. This will help you out tremendously. Let's keep borrowing bits. 1, 2, 3, 4, 5, 6, 7, 8. If we borrow all 8 bits, well, we know we add all these values up for this octet. This octet now has a value of 255 because that is the total of all of these. We would have created 256 total subnetworks, 203.0, 203.1, 203.2, 203.3, 203.4. Those are all separate networks. They will have 65,000 hosts in them each. What's our additive? 1. That's what we were just doing. 203.0, 203.1, 203.2. Networks increase by 1 in this octet. Once we get out of this octet and we start enabling bits down here, what you do is you take this, you draw your line. Since that's the last bit enabled, what do we know? Well, quickly what we'll be able to see is this guy is not valid. It's 255 in this octet as we have here. Now we got to add up going this way. 128 plus 64, that gets us to 192, plus 32 more gets us to 224, plus 16 gets us to 240, to 248, to 252. This mask value now becomes 252. Networks increase by 4. They are going to have 16,000 subnets available. Networks will actually be of 1,024 hosts. Okay, now for our problem we need 7824. You're not going to see 7824 exactly down here. Most likely when you're given a subnet you're not going to find that exact number, but you know this is too little, this is bigger than what we need, but it's always better to go bigger. So in this example right here, draw your line right here. These bits are all off. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bits past our starting 8. 8 plus 13, 21. 21 bits total, slash 21. Our mask value becomes 128 plus 64, gets us to 192, 224, 240, 248. Networks increase by 8 every time. We have 8,192 subnets. We also have 2,048 hosts inside there. So we got our subnet, at least enough networks, subnetworks established to support this. But what happens if they say, give me the 2,348th subnet in this list? Understanding that our networks are now additives of 8. That was the last bit that we enabled. In the third octet, first, second, third octet, let's get a pattern for our networks first so we understand what we're looking at. 23000, 23080, 23016, to 240, to 320, and we see that they increase this way. Now when this guy gets to the top, okay, the last network that he's going to be able to have in this range before this column maxes out is 248.0, because that's going to run you all the way to 255.255, that one network. Then we understand that this column now rolls over to 1. And we will begin counting something like this: 230, 248.0, roll over 23100, to 23180, to 23116. Now this is how we begin to get so many networks. This column right here, every 32nd network, it will reach its end and this guy rolls over. That is the key that we need to understand how to get this high in our values. So if we pull out a calculator at this point, we could say we need 2,348. That's the subnet that we are looking for. Okay. If we divide that by how many subnets we create here before this guy rolls over, it will tell us the value of this octet. So divide 2348 by your 32 and you will see that it gives us 73.375. Okay, don't worry so much about this decimal. We have what we need. That 73 is what's important. So we're going to say 2373.0.0 gets us into the ballpark. Okay. Now what we need to figure out is, well, okay, that's cool, but what network are we exactly at once we do that? Well, to figure that out, understanding that 32 causes the 32 subnetworks here cause us to roll over once, multiply 73 times 32, and you're going to see that at this point we are at the 2,336 subnet. So the 2,337th subnet would be 2373.80. 2,338th subnet, 2373.16, and this continues to climb. What did we need? 2,348, we got this close, which means we still have 12 subnets to go before we max it out. So you can go shorthand at this point, and you could say, clear that out, knowing we're going to add networks by 8 each time. If you do 8 times 12, our third octet will be at 96 when we reach our network. So network 2348 is the value of 23, 73, 96, 0. How far does that run? Well, remember these are additives of 8. The next network actually is 104, so that means he ends at 103.255. 23, 73, 103, 255. That is the broadcast. And 23, 73, 96, 0 is your net ID of the 2,348 subnet. You have a little cheat sheet like this, you kind of create your line. Now, cheat sheets are cool. They're good to use, especially when you're doing something large like this, because that's a big number. That can be tough to find. That can be intimidating. Do not just depend on these guys to walk you through it all the time. Understand subnetting. Play around with this a few times so you can really see how this works. This concept is very, very important. So if you want to take a moment to look at this, put in your mask values in here. 255, 255, 255. Excuse my writing, guys. It's a new Wacom tablet. It's a little interesting. I'm getting used to it, but I think I got to make some adjustments around its sensitivity and all. And it's also pretty early in the morning. I'm kind of getting burnt out, but this is what you're looking at. Put your mask value in here, and these are the bits that you borrow as you move along. Okay. These columns right here, so this is the value of the bit if you borrow it, and if you enable, this is the resulting subnets from doing that, and if you enable, this is the resulting hosts if you do that. Okay. So again, this is James Graves. This was IPv4 subnetting and borrowing bits. I hope you guys grabbed something out of here that you could use. I wish you the best on it, and come back and catch me again for another video. Thanks.